Hello and welcome to the sixth video in the SAT Math series. In this video we're going to discuss inequalities and how to manipulate them algebraically. If you like, you may like the video or subscribe to the channel. Let's begin. The trick with inequalities algebraically is that you can manipulate them just like you can manipulate regular equations, but you must remember that you need to flip the inequality sign whenever you multiply or divide by a negative number. We can illustrate that by, say, doing this problem maybe two different ways. Here, if we take the first step of adding 2y to both sides and maybe subtracting 4 from both sides, we would come up with y plus 2y is 3y, and 3 minus 4 is negative 1. Then maybe we divide both sides by 3, and we would get y is greater than or equal to negative 1/3. And here, if we were to, say, approach this a different way, let me subtract 3 from both sides. And maybe subtract y from both sides. And we would get negative 3y. And here I will deliberately make a mistake and not flip the sign. And you see you get a different answer. If you were to divide by negative 3 here, and you did not flip the sign, you would get y is less than or equal to negative 1/3, whereas over here we got y was greater than negative 1/3, and that's because this is an error here. Okay, so you need to remember that you need to flip the sign whenever you multiply or divide by a negative number. So here's a practice problem. And again, whenever we look to adjust an inequality algebraically, this idea of having to flip the inequality is always in the back of our minds. For instance, this problem reads, which of the following numbers is not a solution of the inequality? But we see we need some simplification here. And already I can see that I can multiply, or I can subtract 4x from both sides, kind of moving the x out of this side. Or I can subtract 3x from both sides. But subtracting 3x will leave a positive x, so I don't even have to worry about the sign flipping. So if I did this as a first step, this is what I would get. 4x minus 3x leaves 1x, or just x. And then we can add 3. And negative 2 is greater than or equal to x. So just try to picture that on a number line. Negative 2 is greater than x, right? So or equal to. So it's all numbers down here are acceptable, and negative 1 will be incorrect here, as it does not lie less than negative 2. Let's look at graphing inequalities. In this case here, we have the expression y is less than or equal to x minus 2. And if you want to kind of picture what that looks like on a graph, you can first start with the line y equal x minus 2. And how would we plot that? Well, we see the y-intercept and the slope being 1, y-intercept being negative 2. And if we just plot this line here, this would be the line y equal x minus 2. But we can look at our inequality, and an inequality is satisfied if y is less than x minus 2. And so if this line is all the solutions to y equals x minus 2, you just need to make y less than that to satisfy the equation. So basically, all points below this line, and not including the line since there's no equal down here, will satisfy these equations. And this concept comes up quite frequently on the SAT, and we'll see a problem where this is applicable. So let's see that in action. Here we have a problem that reads, if the system of inequalities, and then it has this equation and this equation, is graphed in the xy plane, which quadrant contains no solutions to the system? And here it has the quadrants labeled for you, 1, 2, 3, 4. So here, this skill we just mentioned is very useful. This is, if we first start with the line with the slope of 2 and a y-intercept of 1, that line is here. And it looks something like this. And this system here is y is greater than or equal to that. So all the points where y is greater than or equal to that line will satisfy this equation, all these points up here. For the other equation, it's y is greater than 1/2 x minus 1. There's no equals here, let's note that. Our slope is 1/2, our y-intercept is -1. So this line looks something like this, with the slope running 2 for every 1 that it rises here. And I'll use a dotted line because it's not greater than or equal to. And its y is greater than that. So we see that all these points here satisfy this equation. But that's kind of messy with a lot of scribble. But which points satisfy both equations? Well, the points that satisfy both equations are going to be, I'll do that in green, I suppose. So every point here and up, every point here will satisfy both equations. Hopefully that's not too messy. Everything that is above both lines satisfies both equations. And we see that there are solutions in this quadrant, this quadrant, this quadrant, but no solutions in this quadrant. So the answer is quadrant 4. All right, in the next video, we're going to get a little bit more into systems of inequalities as well as systems of equations and how to solve them. I will see you then.